What's up, everybody? Hutch here, and this is your Module 5 Real Numbers Practice Test. All right, now, this table on classifying numbers, remember, classify just means sort them into categories. We gave you some steps to conquer this, and the first step is going to be to actually rewrite some of these numbers in different forms. So a fraction like this, the 21 thirds, I'm going to put equals, and this is actually just 21 divided by 3, right? So we know it's a -7, okay? So that way I can see it as a fraction, I can see it as this other form. 6 is just 6, but if we want, we could also show and remind ourselves that it's also a fraction, okay? -2 thirds, we know that's a fraction and a decimal. We have negative square root of 15. So this is one that I would want to go to Desmos and do square root of 15 and see, oh, it's this really long decimal, -3.8729. I'm just going to put ... As soon as I realize it doesn't end, it doesn't terminate, and there's no repeating, I'm going to just go ahead and right away write irrational. Okay, because I know that's just going to fit in one category. And then 0 is 0. Could it be a fraction? Sure, it could be 0 over 1, right? All right, so now we're going to go ahead to phase 2 of this, which is recording down our hints. Okay, this is really, really important. So natural numbers, remember, naturally, if you ask a toddler how to count, they're going to say 1, 2, 3, and so on, ... And then we add the addition of the 0. We realize, oh, there's 0. 0 exists? Okay, 0, 1, 2, 3, ... And then integers are all of these. So I'm going to do an arrow here, but the positives and the negatives of those. So just be aware, it's positives and negatives of all those prior things. Then we get to rational numbers. Our rational numbers are all of our fractions and our decimals. Okay, we know irrational means not. These are things that we would say doesn't stop or doesn't terminate or repeat. Okay, and then real numbers are all numbers that we use in math. Okay, all right, now, so next step is to check things off. And the first thing I'm going to do is I'm going to go to the real numbers category. And since every single number is a real number, unless you saw the letter like P over there, we're checking that whole category off, and that instantly gets us 5 points. Okay, you can see this entire section here is 15 points. So we want to be really, really careful. All right, now I'm going to start at natural numbers and work my way down. Okay, and I'm going to ask these questions of, starting here, if I say 1, 2, 3, and so on, would I say -7? Well, no. What about 6? Yes. No to the -2 thirds, no to the irrational, and I wouldn't say 0 either. Okay, so now we go to the whole numbers. If I say 0, 1, 2, 3, and so on, will I say -7? No. Will I say 6 still? Yes. Will I say 2 thirds? Nope. Irrational? No. 0? Yes. Okay, now integers. Okay, if I say 0, 1, 2, 3, and it's negatives, will I say -7? Yes. Will I say 6? Yes. Will I say 2 thirds? No, not yet. I haven't learned fractions yet, right? Will I say that irrational number? Obviously not. Will I say 0? Yeah. Okay. All right. Now on to fractions and decimals. Okay. If I know all positives, negatives, and fractions and decimals now, okay, could -7 be written as a fraction? Well, yeah, it's right there, duh, right? So yes. Can 6 be written as a fraction? Yes, 6 over 1. Can 2 thirds be written as a fraction? Well, it is. Can the irrational number be written as a fraction? And remember, the answer is no. Okay, so we skip that. Can 0 be written as a fraction? Yeah, 0 over 1. Okay, irrational, we already made a note about this. We already know there's only 1. Okay, and then real numbers, and we're done. And then it's a 15-point thing, so I would count through and go, do I have 15? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 16, which probably means that Mr. Hutch miscounted when doing this and calculating the total points. But that's the ones that you're checking off there. All right, so let's go ahead and head to the next section. This one says evaluate each expression, which just means solve, but there's no equal sign. Okay, so it also says if necessary, and then plot the letter on the number line. It only says if necessary because negative 3.4, nothing needs done to that. Okay, negative 9/4, we are just pulling out your calculator. You don't need to do this in your head, and your first step is going to be to actually record your simplified expression or your evaluated expression. Square root of 17, so I'm going to say square root of 17, and I'm just going to round to the nearest tenth, so 4.1, because we're just plotting things. So it's approximately that. 5 halves, 5 divided by 2, 2.5, and then negative 0.9 is there, 2.31 is there. Okay, so we have enough information to go ahead and plot these. First thing that I would always do is I like to highlight the negatives so that I'm making sure I'm taking care of them, and then my positives, so I have 3 and 3. Okay, so let's go ahead and through this. I'm going to start with the negative 3.4. So I always start at 0 and think this way, 1, 2, 3, and then 0.4. Okay, that way I don't accidentally go to the 3 and then go 0.4 this way. So negative 3, always know where half is, okay, because I know this is a little bit under half. So I'm going to draw my line right here, and I'm going to put an A. Okay, next one, so this one's done. I'm going to go ahead and do negative 2.25. So starting at 0, I'm thinking 1, 2, 0.25. Okay. All right, and 0.25 is a quarter, so that's a quarter of the way there. So right about there, and we have spot B. Okay, next one, I have my letter E, which is negative 0.9, so not quite 1. So start at 0 and go over almost to 1, and we have letter E. Now I'm going to go ahead and do my positives. Okay, so I have, we can do them in any order, doesn't really matter. I have 4.1, so a little bit more than 4 is C. We have 2.5 is perfectly halfway, so make sure it's perfect, is D, and then 2.31 is a little bit under that, right here, and this is F. Okay, make sure you have them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go, 6 points. All right, next one. Evaluate. That means actually like write their official answer. Okay, because notice the next section says estimate. And estimate, we're going to do that work to show what our estimating is, even though we have a calculator and can make sure it's right. Okay, all right, so square root of 49. What times what equals 49? 7. Square root of 36 is 6, and then we make it negative. What times what equals 1? Well, 1. What times what equals 144? 12. What times what equals 64? 8. And then make it negative. Don't forget those. Those are really important. All right, now we're estimating. So, I mean, let's be honest. We can see the square root of 90 is 9 point something. It's really close to 9.5. But for this one, I have to show the closest perfect squares above and below the given number. Okay, so that's something I have to do, which is also called show your work. Okay, that's why it's 10 points. You get a point for each answer and a point for your work for each one. Okay, so remember what we did here. We asked what times what gets me close to 90. Okay, so 10 times 10 is 100. So that's probably on the right side. 9 times 9 is 81. So yep, so I'm going to put my 9 here and show the 81. I'm going to put my 10 on this side and show the 100. Okay, and now I just have to decide what it's closest to. Well, it's about 10 away here, and it's actually pretty close to 10 away here. Okay, it's only 9 away here. So it's closer to the 9, but it's really close to half. So I'm going to say this one is 9.4 would be my guess. Now, we would always want to check on the calculator, and you can see 9.48. 9.5 works as well. Okay, so anything I would say 9.4 or 9.5 would be your good guess on that one. Okay, so this is what I would accept is either of those would be fine. Okay, all right, square root of 32. I know 6 times 6 is 36, so I'm going to put this, and 5 times 5 is 25. Now, if I mess that up, then I would just erase it. Okay, but I found the one above and below. Okay, now what's it closest to? Notice, remember, my tip is to always write how far away they are. So this is only 4 away. 25 to 30 is 5 plus 2. This is 7 away. So what's it closest to? It's closer to the 6. Okay, so between 5 and 6, I'm going to say it's not super close to 6, so maybe we say 5.6 or 5.7. So I'm just going to go with 5.7 for this one. Okay, but I would, of course, always check. Okay, square root of 32, 5.65, which would actually round to 5.7. So I think 5.6 or 5.7 would work fine on this one. Okay, all right, square root of 132. So I know 12 times 12 is 144. 11 times 11, if you don't know it, type it in, is 121. So those are my numbers. 144. 11 times 11 is 121. Okay, what's it closest to? So 21, 31, 32. We're 11 away this one. And 32, 42, 43, 44. We're 12 away on this one. Really close to half, though. Okay, so I mean, 11.5, 11.6. Oh no, it's closer to the 11. So 11.4, 11.5. I'm just going to go with the 11.4 just because it's a little closer to the 121. Okay, but I bet it could be 11.5 too. Let's see. Square root of 132 is 11.48, which would round to 11.5. Yep. So either of those would be really good estimates, okay, and would be acceptable. All right, let's go ahead and do square root of 50. So 5 times 5 is 25. That's way too short. So you can see how I'm talking through them. 6 times 6 is 36. No. 8 times 8 is 64. That's a little bit big. 7 times 7 is 49. That's really close on the low end. So I think I found my number here. So that means an 8 would go here, and 8 times 8 is 64. Okay, we're obviously really close to 7, and we're 14 away to 64. So this one's an easy, definite. I'm going with 7.1. Okay, it's really, really close to 7. All right, so let's see. Square root of 50. Yep, 7.07. So definitely 7.1. I guess I could give you 7.2, but really 7.1 is the obvious choice. All right, now let's go ahead and estimate this irrational number. So square root of 62, I know 8 times 8 is 64, so I'm going to make a guess that that's the one here, and then we'll test it out. 7 times 7 is 49. Yep, there we go. I got the one high, one lower. Okay, now what's closer? 62, this is only 2 away. Okay, I know 49 to 62 is a lot more, so I don't really need to even look at that. I just know that we're really close to the 8, so I'm going to say either 7.8 or 7.9. I'm going to go 7.9 on this. I'm just making a guess. You could pick either or. Okay, and let's see, square root of 62, 7.87. Yep, so 7.8 or 7.9 would be acceptable for this one. Okay, so there you go. There's that page, and then you just have 2 problems on the back, which is order of operations. So the first thing I would do is record down your germ DOS. Okay, and remember that square roots fit in grouping, but they're also over here with exponents and roots. So the first thing you have to do is take care of all the operations inside the square roots because they behave almost like parentheses or grouping. Okay, so if we go here, this is a 3-point question. We need to go ahead and solve certain things first. So I see this minus a negative, and right away I want to go ahead and KFC that, right? Okay, so KFC is happening first. After I do that, we can go ahead and add that up because that's sort of like our grouping in there. It's almost like parentheses are occurring. Okay, so we have 91 plus 9, which we know brings us to 100. So I'm going to do a rewrite here. So I have negative 5 minus the square root of 100. Okay, so this is where I'm getting my next point. Okay, all right, so now we're going to go ahead and move on to the next stage, which will be to solve this. Okay, so we have negative 5 minus square root of 100. 10 times 10 is 100. Okay, and then my final thing, or my third point, is negative 5 plus a negative 10, which is negative 15. And there we go. Okay, so it's a 3-point question, and I can see I did 3 steps of work here. Okay, all right, let's go to this one. It's a 5-point question. Okay, first step is in GermDOS is taking care of any grouping. I do know that I have hidden parentheses, right, in a numerator. Okay, so that's something to be aware of. Okay, so I need to go ahead and solve all these things before doing the big division there. Okay, any exponents are roots? Yeah, we have both actually, right? So let's take care of all of our exponents and roots. Okay, so I can make some little notes. Square root of 64 is 8 times 8 is 64. So now, and bring this up. So I have a negative 8 for this, and then this is 4 times 4. Okay, and then we make it negative because this isn't in parentheses. Okay, so it's really this. Okay, so 4 times 4 is 16. So this right here is a 16. So now let's go ahead and do some rewrites. You really could just solve the square root of 16 down here. 4 times 4 is 16. Okay, but I want to rewrite this to organize. I got to be really careful because I have lots of negatives and things like that, right? All right, so we have negative, the square root of 64 was 8, minus 4 times 4 was 16. So I'm being really careful and cautious and methodical here. Divided by the square root of 16 is 4. So there's my rewrite, okay? And that's really, really important for you to have, okay? All right, now remember this top is still sort of in parentheses, right? I got to take care of that before I do the division. So negative 8 minus 16, or negative 8 plus a negative 16. You could absolutely do it in your head. It's just a test, so I wouldn't. So same signs, adding key, 8 plus or 16 plus 8, and you got 24, but it's negative, okay? So I'm going to do my rewrite. I have a negative 24 divided by 4, okay? And now I know 24 divided by 4, but we definitely want to type it in either way, okay? And you can see we're left with a negative 6 as a final answer. So very, very doable for you. Just be really, really careful, okay? All right, that is your practice test. If you have any questions, let me know.